breakout honor students. Okay, so today is the day that we're going to be talking about the horizontal translations for trig graphs, which is otherwise known as a phase shift. Okay, so we'll be repeating what we've done with the other graphs as well, but we're going to, meaning we're going to repeat dilations, the reflection, the translations, but we'll just be adding one more on top of it. Okay, so let's jot that down. What our topic will be here. Yeah, horizontal translations. Okay, otherwise known as phase shifts. Okay, so best way to go to learn this is to go through an example. Okay, so I've got two to do with you. One that we'll do entirely. The second one that we'll just kind of get set up. I don't think we should have to do entirely, although we'll see what we can. I don't make this video too terribly long. All right, so first one is y equals -2 sine 4x plus pi plus 3. Okay, so as we've stated before, you're looking for your dilations first. Okay, your dilations happen when you have multiplication. This one is a dilation of 2 to the y's because the 2 is outside, so the multiplier is a scale factor. This one right here is a dilation of 1/4 to the x's because remember you have to reciprocate the multiplier to be the scale factor. Okay, now this is our sine function. Okay, so right away I'm actually just going to get going with making this graph right here. Okay, and get my x-axis going, the y-axis going right here. Oops. Okay, and as we just said, okay, let's just kind of scroll back and peek here. All right, we've got dilation of 2, okay, to the y, which is going to affect the amplitude. Okay, so our sine graph is going to go as high as +2, and it's going to go as low as -2 because we've vertically stretched out by scale factor 2. Here we're going to have the period affected. Okay, dilation of 1/4 to the x's. Okay, means that we're going to compress our cycle by scale factor 1/4. Right, we're going to compress it in. So that standard period, which is 2 pi radians, is going to be multiplied by 1/4, and that is going to give us pi over 2 as the new period. Now what that means is we're going to have to come up with our scaling, like what we're going to count by, all right? And that is going to be that you always divide by 4. Well, since I've got a fraction, division by 4 is multiplication by 1/4, and that's going to give us a scale of pi over 8, okay? So let's remember that. We get the sine function, amp is 2, scaling is pi over 8. So let's come over here, okay, and I'm going to give myself an amplitude of 2. I'm just going to go up 2 boxes, 2, down 2 boxes to -2, and I've got my scaling, which is pi over 8. So with the sine function, okay, I know that every interval, okay, gives me my next critical point, which is going to be at pi over 8 radians. All right, so I'll go up to my maximum here, okay, midline to maximum, and 2 pi over 8, which is pi over 4, will bring me back down to my midline. Okay, then another pi over 8 radians, which is 3 pi over 8. I'll be down here at the minimum, right? And then another pi over 8 radians later. So at 4 pi over 8, which reduces down to pi over 2, I'll be up here at my midline again. So that is just one sine cycle, okay, that I'm gonna sketch here. I mean, if the directions say 2 cycles, then you could just do a second one going in the positive x direction, or you could just do a second one going in the negative x direction, okay? And then just keep counting by pi over 8s to the right, or go by pi over 8s to go in the negative. But that's not the end of the problem by any stretch, all right? So now we've got the reflection to do, okay? So I'm going to switch colors here. So after dilations, we look for reflections. So that negation that's out in front there, that is a reflection over the x-axis, okay? Remember, even if you have that negation inside the parent function, which would be a reflection over the y-axis, we're never going to do reflection over the y-axis, because if it's the sine function, the reflection over the y-axis would just be equivalent to the reflection over the x-axis. So you want to know how to do that, reflection over the x-axis. Even if it was the cosine function, you would never reflect over the y-axis and waste your time doing it, because the graph would just repeat upon itself. All right, so we want to do this one next, reflect over the x-axis. So the midline points will stay right there on the x-axis, okay? And then the max becomes the min, and the min becomes the max, and I just connect those dots, and there we go. All right, and if you're doing this on the same set of axes, you don't want it to get too crowded, so then I'll just quickly erase. You can make a new set of axes for yourself. You can use the color at least this way, maybe like it stands out and it doesn't get too crowded. Just do it in pencil and just do it lightly and then just erase it, okay? So the next thing that you're gonna do is a translation, and I do the translations in parts, okay? So the first translation that we look at is the vertical, so that's that +3, all right? So that's going up 3, so that's gonna change that midline, okay? Remember we talked about that on Friday, okay? And so what we do, okay, is we put a new midline at y equals 3. You don't really have to do this, I just think it's a nice thing, because you know what the graph looks like right now with respect to the x-axis as the midline. So now that dotted line that's at y equals 3, that's what your graph is still gonna look like, just with respect to that line as your midline now, okay? So the whole graph just moves up 3. So all these midline points, okay, are just right at a y value of 3. Okay, this minimum that was at -2, that goes 3 units up, so that's at a -1 now. And then that maximum that was at 2, that goes 3 units up, and now that's at a y value of 5. Okay, so notice here, okay, and it's still exactly what that graph looks like, you just moved it up 3 units. Okay, so we're gonna erase now what was in the purple. Okay, just don't want the graph to get too crowded there. And last but not least, okay, let's go talk about the phase shift now. Okay, the last one to do, okay, this phase shift is a little bit harder than the other transformations to think about. Okay, it's not really harder to do, it's just easier to make a mistake with it, because, and you have to remember what we already talked about earlier in the year, when you have the addition or subtraction inside your parent function, okay, which we do, we've got that plus pi, okay, going on inside the parentheses, so we know that there's a horizontal translation. You have to make sure that that is in factored form, okay? You absolutely have to make sure that that's in factored form. So we're gonna take that quantity and we're gonna write it as 4 times, okay, whatever that coefficient of the x is, no matter what it is, that multiplier that told you that you were gonna have, your horizontal dilation that told you that you're gonna change your period, that has to be factored out, and then what is left, okay? So x plus what, okay, multiplied by 4 would be the same as saying 4x plus pi. So hopefully everyone's got a thought right now, okay? You just gotta eventually do this on your own for homework. So that would have to be pi over 4, right? Because then 4 times the pi over 4 would get you right back to the pi. So now we know, okay, so let's see what color I shall go to. I'm gonna go to the orange, okay? So now I know right here, okay, that is going to be my rating measure to horizontally translate by. Okay, it's going to be to the left, because remember the horizontal translation is the opposite way, okay, so you're gonna go to the left, and it's gonna be negative pi over 4 comma 0. Okay, so what we wanna do is we wanna come back to this graph, okay, and we wanna look to see how many boxes it took to get to pi over 4, okay, pi over 4 radians, okay, that was 2 intervals worth, okay, pi over 4 radians is 2 intervals worth. So for me, I let every box be 1 interval, so I know that these critical points are all gonna go 2 boxes to the left. Okay, so that's gonna be 2 boxes over there. It's gonna be at negative pi over 4, and this minimum is gonna be right here, okay, and that's gonna be at negative pi over 8. This midline is gonna come over and be right there on the y-axis. Okay, this maximum is gonna now be at pi over 8 comma 5, and then that midline is gonna be at pi over 4 comma 3, okay? So I just take my cycle and I just send it to the left, pi over 4 radians, okay? And again, take a look at what you've already got scaled on your x-axis. This is why it's important that you know how to calculate your period, and that you know how to get your interval for your cycle within the period, because that tells you, you know, how many units every how many units every box is, and then that helps you do a proper phase shift, okay, proper horizontal translation. So I'm going to just erase what's in the blue, okay, here. Okay, and if you have to do a second cycle, like I said, you could go to the right, okay, so then that would just be back to midline, minimum, midline, max, midline, okay, and if you're going to go off to the left, and this would go up here to max, then midline, in, midline, like that, okay, so that'd be infinitely many cycles. You can keep doing that over and over again. And then you would want to make sure that everything is scaled on your x-axis properly. Let me actually go ahead and change this to being done in black. And of course I erased the axis, so I got it back again. All right, so you're counting by pi over 8s, right? So 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8. That would mean this is, oh, I thought I changed it. Change it to black. Anyway, so this would be at 5 pi over 8, and the next one would be at 6 pi over 8, which would reduce to 3 pi over 4, okay? And then going in the negatives, okay, that's easy, all right? So that would be negative pi over 8, and then negative pi over 4. You already got it scaled in the positive x direction, so then you would just have everything scaled in the negative x direction. And for however many cycles that you are asked to graph, you want to always make sure that every critical point of your graph, so all your mins, your maxes, and your midlines, that they have a corresponding y value, okay, from the y-axis, and a corresponding x value ready measure along the x-axis. You always have to make sure that your axis is each axis is scaled, all right, according to, with respect to, all of your critical values, okay? So hopefully you got the gist of the phase shift there. So let's just try one more example, okay? Let's try a little bit more. Okay. And this time we're going to take a look at y equals 4 cosine of 2 pi minus 3x, and then minus 1. Okay? So give you a chance to get that copy down. And then while we're at it here, actually, let's go and get ourselves a set of axes drawn. See what we have with the graph. Okay, so we are going to have a dilation of 4 to the y's, which hopefully everyone knows now, right? This is going to affect the amplitude. Okay, tricky with getting that vertical dilation here, ladies and gentlemen. Okay, look at that expression inside the parentheses. It's 2 pi minus 3x. So your independent variable is x, right? The multiplier of the x, that's what gives you your scale factor for your horizontal dilation. So if you want, I mean, I think it might be wise of you to write this as negative 3x plus 2 pi, even though it's probably not the way it's going to be presented to you. It might be better for you to rearrange it and put the x term first, because then you can really see that that multiplier of 3, that's what's actually going to give you a scale factor of 1/3 for your horizontal dilation. Okay, and that affects your period. Okay, your standard period for sine and cosine is 2 pi, but we're multiplying it by that scale factor of 1/3, so that gives you 2 pi over 3 as your period. Now, remember, you have to figure out appropriate scaling. Okay, so there's 4 equal intervals. Again, you could start off by saying that you're dividing it by 4, but that's really just the same thing as saying that you're multiplying it by 1/4, and reduce out there as you're multiplying straight across, and you get a scaling of pi over 6. All right, so let's just make our initial sketch for that. We got an amplitude of 4, a scaling of pi over 6 for the cosine function. All right, so let's get our y-axis scaled to 4, 1, 2, 3, positive 4, that's where I know my max is gonna be, 1, 2, 3, negative 4, that's where I know my min is gonna be. All right, and then pi over 6, remember we said, right, am I remembering correctly? Oops, hang on, let me go confirm. Yep, pi over 6, okay. And then, you know what, this time, how about we do 2 boxes to pi over 6, all right? So pi over 6, 2 pi over 6, so that reduces down to pi over 3. 3 pi over 6, okay, that reduces down to pi over 2. And then 4 pi over 6, okay, that reduces down to 2 pi over 3. And yeah, that's exactly what I have my period as, so I'm good to go. Cosine always starts at the maximum, right? Then it goes to midline, okay? Then it goes to minimum. Then it goes to midline, and then it's back to the maximum. Okay, so there's your sketch with just your dilation. So now let's see, dilations plural, okay, so let's see what we have next. Okay, now we're gonna see about any reflections. Well, I see this negation, okay, let me do purple here, okay, so I see this negation right here inside, which is gonna be a reflection over the y-axis, okay, but if I come to my graph, okay, now think about it, right, I don't know if I gave myself enough room to do this, okay, but what would the cycle look like if I kept going to the left? I did a second cycle to the left, right, I'd have that critical point, then I'd have the midline, then I'd have the minimum, then I'd have the midline, oh, I'm just gonna make it here, midline, back to max, right? So if I reflect over the y-axis, it doesn't look any different. So there's no point in doing that, right? I mean, the graph isn't gonna look any different, so just leave that, okay? Then we go to our translations. So I suggest you the vertical translation next. So this is gonna go down 1, okay? So I've got that -1 there, okay? So it's gonna go down 1. So I come to my graph here, and I'm going to sketch in a new midline, okay, of y equals -1. And these midline points are just gonna go right there on the midline. Okay, they're just gonna move down 1. And my maxes go from 4 to 3. Okay, so and then my minimums go from -4 to -5 because they go down 1. Okay, and then I'm just gonna connect here. Oops. Here to here. Okay, and then I'm gonna just erase what's in the black. Okay, just so it's not too crowded. There we go. Okay. Well, let me see if I can get those dots to just, the whole axis went away. I'll put that back again. Okay, so now we're on to the last thing. Actually, we are just gonna do the whole problem here, why not? All right, so on to the last thing, which is the phase shift, right? The horizontal translation. So I'll do this in the orange, right? So we know that we've got a horizontal translation to do because of the addition that's inside the parentheses there, but we have to make sure that that is in factored form, okay, in order to properly state what the phase shift is. Now, we factor out that -3, okay, and then we're gonna say what's left inside the parentheses, okay, so -3 times what quantity? So x, okay, well, if it's a plus and I'm factoring out a negative, I know for sure it's not gonna be a negative. And 3 times what would get me right back to 2 pi. When I factor out a 3 from 2 pi, that would leave me with 2 pi over 3, okay? So now I know that my phase shift, right, is going to be 2 pi over 3 radians to the right, okay? So come to my graph. Oh no, why did that just happen? Uh-oh. Huh. What is happening to my graph here? Always touch the wrong thing and then all of a All right, well anyways, 2 pi over 3. Here's the deal. This is what's very, very interesting about this graph, okay? Is I got a phase shift of 2 pi over 3. Well, look at what the entire period is. The entire period is 2 pi over 3. So if I phase shift exactly 2 pi over 3, I mean, doesn't that just make the cycle just phase shift right onto itself? Anyway, that does not happen often, okay? It really does not happen often at all that is the case, but that's what happened in this problem, all right? So you would just, you know, and if it was something different, obviously, then the graph would probably not map right onto itself, but that is just what we had here. So anyway, there you go. Hopefully you understand how to arrive at your phase shift and how to apply them. Okay. All right.